we had to ask her to slow down so that we could actually see what she's doing. Throughout the sewing process, these cotton gloves have been inside out. This next machine turns them right side in, transferring them onto a heated hand form. The machine then presses each glove onto the form. The gloves drop down to a conveyor belt below and are transported to a worker who inspects, then pairs up the left and right. Elsewhere in the factory, workers prepare the PVC solution. The recipe varies according to the glove model, but generally consists of colouring and 5 to 8 different chemicals. An antibacterial and antifungal solution are added to combat odour from hand perspiration. To apply the PVC, workers slip a metal form into the thumb of each lining, then put the lining onto a thumbless hand form. If the hand and thumb forms were in one piece, it would be difficult to remove the stiff PVC glove afterwards without tearing. The linings go through what's called the singer, a propane flame that burns off any dust or loose threads. Then it's into the PVC bath. The basin of liquid PVC moves upward, coating the liners. As the basin descends, the excess drips off. Then the gloves go for a spin under infrared lamps for about 45 seconds. The spinning spreads the PVC uniformly so that it doesn't accumulate on the tips of the fingers, forming clumps. The heat ensures it dries evenly. After a second coat, the gloves pass through a propane-fired furnace for about 20 minutes at 190 degrees Celsius, then through a cooling chamber for 5 minutes. For glove models with extra strong grip, PVC chips are blown onto the first coat of PVC while it's still wet. When the gloves go through the furnace, the heat embeds the chips. After cooling, the gloves are dried and cured and ready to handle a hard day's work. Coming up in How It's Made. Thermoformed glass, art that's fragile but functional. And fire engines, custom built to save lives. See you after the break. Welcome back to How It's Made. Later we look at fire engines, custom made to save lives. But first, decorative glass objects can be blown or thermoformed, two very different glass-making techniques. In glass blowing, the artisan shapes hot glass by rolling it and blowing air into it. Thermoforming is more of a moulding process, better suited for making flat objects. When you look at these magnificent pieces, it's hard to believe they begin as run-of-the-mill window glass, which comes in ready-made panels in thicknesses ranging from 3 to 10 millimeters. The first step is to measure the overall dimensions of the glass panel, then divide it into pieces, each slightly larger than the object it will become. This panel will be turned into large decorative plates, so it's divided into 3 squares, each about 35 centimeters in diameter. Workers place each square over a paper pattern. Then, using a glass cutter, they score the shape of the plate. Then they apply pressure with a rubber mallet to separate the glass along the score line. The excess is cut away, broken off with a few gentle taps. Now they position the plate-shaped glass over a drawing and begin the artwork, first tracing the outline. Now workers embellish the design and fill in the details. Enamel paints, specifically designed for painting on glass, are used. Once the brushwork's done, a paint gun applies the background colours and shading. The glass has been cut and decorated, but it's still perfectly flat, so the next step is to mould it using extreme heat, hence the term thermoformed. The mould used is made of fireproof materials, designed to withstand the high temperatures inside the kiln. The glass is carefully laid over the mould. Several different mould pieces are made at the same time. In the intense heat of the kiln, the glass will melt and take on the exact shape of the mould, right down to the most intricate textural detail. These small pieces of glass will become the